Hello everyone. Consider this. From the moment we wake up, our day is filled with a series of small challenges. Maybe your alarm didn't go off, or perhaps you can't find matching socks. These are problems, and we solve them, almost without thinking. Problem solving isn't just for scientists in labs or engineers building bridges. It is a fundamental human skill. It's a part of what makes us so successful as a species. We see an issue, we think about it, and we find a way forward. It's an everyday superpower that we all possess, and like any superpower, we can train it to become even stronger. In our schools, our jobs, and even in our homes, the problems can get a bit more complicated than missing socks. Maybe a team project at work keeps missing its deadlines, or the cookies you bake always come out a little burnt on one side. When faced with these bigger, stickier problems, just winging it might not be enough. We need a more structured approach, a roadmap to guide our thinking. Having a plan helps us avoid guessing, which can waste time and energy. It helps us look at the problem from all angles, ensuring we don't just fix a symptom, but find the real underlying cause. This is where some truly neat tools come into play. Think of them as special gadgets for your brain. Methods like the 8D process, the 6M fishbone diagram, and the 5 Whys technique are structured ways to tackle challenges methodically. They were developed by clever people in industries where getting it right is incredibly important, like manufacturing cars or building electronics. But here's the cool part. You don't need to be an engineer to use them. These tools are brilliantly simple and can be applied to almost any problem you can imagine, making you a more effective, efficient, and confident problem solver. So let's go on a journey together. We're going to explore these amazing problem-solving frameworks. We'll break them down, see how they work with simple examples, and understand how they can help you become the go-to problem solver in your group. Whether you're a student, an office worker, an artist, or a manager, learning these techniques will give you a powerful new set of skills. You'll be able to face challenges not with frustration, but with a sense of curiosity and a clear plan of attack. Let's get started. Science. First up is a powerhouse method called the 8D process. The D stands for disciplines, or what you can think of as 8 dedicated steps you follow to solve a problem from start to finish. This isn't a tool for finding those missing socks. It's designed for bigger, more complex issues, the kind that might affect customers or cost a company time and money. The real magic of 8D is that it's all about teamwork. It recognizes that big problems are rarely solved by one person working alone. Instead, it brings together a group of people with different skills and knowledge to tackle the issue from all sides. Imagine you work for a company that makes backpacks, and you suddenly start getting complaints that the zippers are breaking. This is a perfect scenario for the 8D process. A broken zipper might seem simple, but the cause could be anything from a bad batch of zippers from a supplier, a problem with the sewing machine at the factory, or even an issue with the design itself. A single person might not have all the answers, but a team composed of someone from design, someone from manufacturing, and someone from purchasing can put their heads together to find the real root cause and a lasting solution. The 8D process is incredibly thorough. It's like being a detective, a scientist, and an engineer all at once. It forces you to not just jump to conclusions, but to gather evidence, test your theories, and make sure that when you fix the problem, it stays fixed for good. It's a structured journey that starts with planning, moves through investigation and correction, and ends with prevention and celebration. Following these 8 disciplines ensures that no stone is left unturned and that the solution you implement is robust, well thought out, and effective in the long run. Think of it as a recipe for success. Just like you'd follow a recipe to bake a perfect cake, you follow the 8D steps to achieve a perfect solution. Each step builds on the last, creating a logical flow that prevents you from getting lost or overwhelmed. It guides your team from a state of, "Oh no, we have a problem," to "We did it and we have a system to make sure it never happens again." This disciplined approach transforms chaotic situations into manageable projects with clear goals and measurable outcomes, which is incredibly valuable in any professional setting. The 8D journey begins before the first step, with something called D0 plan. This is where you recognize that a problem is big enough to need the full 8D treatment. For our broken backpack zippers, you decide that this issue is serious enough to assemble a team. The first official discipline, D1, establish the team, is next. You would gather a cross-functional group, perhaps an engineer who knows about materials, a factory floor supervisor who understands the sewing process, and a quality control inspector. A team leader is chosen to guide the process and keep everyone on track. With the team assembled, you move to D2. Describe the problem. This step is all about getting specific. It's not enough to say the zippers are breaking. The team needs to ask detailed questions using the who, what, where, when, why, how, and how many framework. Who is affected? Students who bought the Explorer 2.0 model. What is breaking? The main compartment zipper pull tab. Where is it happening? It seems to be reported most from online sales. When did the complaints start in the last month? How many have been reported? About 50 so far. This level of detail creates a crystal clear picture of the problem, preventing the team from chasing ghosts. This detailed problem description is critical because it sets the boundaries for your investigation. Without it, the team might waste time looking at other backpack models or different types of failures. By narrowing the focus to the Explorer 2.0's main zipper pull tab from the last month, the team can direct its energy far more effectively. Now, the team has a precise target. They can start gathering data specifically related to this model, this component, and this time frame, which makes the entire process much more efficient and manageable for everyone involved in the investigation. Defining the problem clearly also helps in communicating the issue to stakeholders outside the team, like upper management. Instead of a vague report, the team can present a concise and data-driven summary of the situation. This builds confidence and shows that the team is taking a methodical, professional approach. This step essentially builds the foundation for the entire problem-solving house. If your foundation is shaky or unclear, everything you build on top of it will be unstable. D2 ensures your foundation is solid rock. Now that the problem is clearly defined, the team must act quickly to stop the bleeding. This is D3. Develop interim containment actions. The goal here isn't to permanently fix the issue, but to protect any more customers from experiencing it while you find the real solution. For our backpack company, the team might decide to immediately halt all shipments of the Explorer 2.0 model. They might also pull all existing stock from warehouse shelves and contact retailers to have them remove the backpacks from sale. This containment action is like putting a bandage on a wound. It's a temporary measure to prevent further damage. With the immediate crisis contained, the team can now focus on the investigation. This brings us to D4, determine and verify root causes. This is where the real detective work begins. The team needs to figure out why the zipper pulls are breaking. This is a great place to use other tools, like the fishbone diagram or the 5 whys, which we'll talk about soon. The engineer might investigate the metal alloy of the zipper pull, the factory supervisor might review the sewing machine settings, and the quality inspector might check quality reports from the zipper supplier. They might discover that their supplier recently switched to a new, cheaper metal alloy that is more brittle. Once the team has a theory, the new metal alloy is the root cause, they must move to D5, choose and verify permanent corrective actions. It's not enough to just guess, you have to prove it. The team could order a test batch of backpacks made with the old, stronger alloy and another batch with the new one. They could then run stress tests on the zippers of both batches, pulling on them with a machine until they break. If the zippers made with the new alloy break much more easily, they have verified the root cause. The permanent corrective action would then be clear. Switch back to the original, more reliable zipper supplier immediately. This verification step is absolutely crucial. It separates professional problem-solving from simple guesswork. Imagine if the team had just assumed it was a sewing machine issue and spent weeks recalibrating equipment only for the zippers to keep breaking. That would be a huge waste of time and resources. By testing their hypothesis and verifying the root cause, the team ensures that the permanent solution they propose will actually work. This evidence-based approach is at the heart of the 8D method's power and reliability, making sure the fix is the right one. Having verified the permanent fix, it's time for D6, Implement and validate permanent corrective actions. This is where the solution is rolled out. The backpack company would formally terminate the contract with the subpar zipper supplier and sign a new one with the trusted, original supplier. They would update their material specification documents to require the stronger metal alloy. Then, they would start a new production run of the Explorer 2.0 backpacks with the corrected zippers. Validation involves inspecting and testing this new batch to confirm that the zippers are indeed strong and that the problem has been solved for good. But fixing the problem once isn't enough. We need to make sure it never, ever happens again. This is the goal of D7, prevent recurrence. The team needs to look at the bigger picture. How did we end up using a bad supplier in the first place? Maybe the process for vetting new suppliers was weak. The team might recommend a new company policy that requires rigorous material testing for any new component from any new supplier. They might update training manuals and quality control checklists. This step changes the system itself, making it more robust and less likely to fail in the same way again. Finally, after all that hard work, we arrive at the last step, D8, recognize the team. Solving a complex problem is a major achievement, and it's important to celebrate it. The company leadership should formally thank Jane, Carlos, Aisha, and the rest of the team for their dedication and clever work. This recognition could be a mention in the company newsletter, a small bonus, or a team lunch. Celebrating success boosts morale, reinforces the value of the 8D process, and encourages everyone to be proactive problem solvers in the future. It's the perfect way to end a successful problem-solving adventure. And so, the 8D process comes full circle. It doesn't just put out the fire, it fireproofs the building. For our backpack company, they not only fixed the broken zippers, but also improved their supplier approval process, preventing similar issues with buttons, straps, or fabrics down the line. The benefits are huge improved product quality, higher customer satisfaction, and stronger internal systems. It's a comprehensive method that delivers lasting, meaningful results by turning a crisis into an opportunity for improvement. Let's switch gears to another fantastic tool, often used during the root cause analysis step, or D4 of the 8D process. It's called the fishbone diagram, or the Ishikawa diagram, named after its creator, Kaoru Ishikawa. Why fishbone? Well, because it looks like the skeleton of a fish. You have a long spine leading to the fish's head, where you write the problem statement, like, say, backpack zippers are breaking. Coming off the spine are several smaller bones, which represent categories of potential causes. It's a visual way to brainstorm and organize all the possible reasons for a problem. The most common version of this diagram uses the 6 M's as its main categories, or bones. The 6 M's stand for manpower, which is people, method meaning processes, machine for equipment, material, which covers supplies, measurement for data or inspection, and mother nature, which is the environment. By thinking about potential causes within each of these 6 areas, a team can conduct a really thorough and organized brainstorming session. It prevents the team from getting stuck on just 1 or 2 obvious ideas and encourages them to explore a wider range of possibilities they might not have considered otherwise. This structured approach helps to uncover the less obvious hidden causes. Let's apply this to our broken zipper problem. For manpower, the team might ask, was the sewing machine operator properly trained? Were they tired or rushed? For method, they could ask, is our standard procedure for sewing zippers correct? Has the process changed recently? For machine, they might consider, is the sewing machine calibrated correctly? Is a part of it worn out? For material, they'd ask, did our zipper supplier change? Is the metal alloy for the pull tab different? This is actually the category where they'd likely find our root cause from the 8D example. Continuing on, for measurement, the team could question their inspection process. Are we testing the tensile strength of the zippers when they arrive? Is our testing equipment accurate? Finally, for Mother Nature, they might explore environmental factors. Is the high humidity in the factory warehouse causing the metal to corrode over time? Is the temperature affecting the materials? By systematically going through each of the 6 M's, the team casts a wide net, making sure they don't miss any potential contributing factors. The fishbone diagram organizes all these ideas into a neat visual map of the problem's landscape. Let's dive a little deeper into the 6 M's to see just how versatile they are. The first M, manpower, relates to any human element. This isn't about blaming people, but about understanding human factors. Think about a school project where a presentation turned out poorly. Under manpower, you might list causes like team member was sick and couldn't complete their part, lack of communication between group members, or not everyone had the right skills for their assigned task. It's about the human resources and how they are utilized, trained, and coordinated within the process being examined. The second M is method. This category covers the processes and procedures you follow. It's the how of your work. Imagine a cafe where the coffee sometimes tastes bitter. Under method, the team could brainstorm. The steps for brewing are not written down. Different baristas use different amounts of coffee grounds, or the water isn't being heated to the correct temperature consistently. These are all issues with the process itself. Standardizing the method is often a powerful way to improve consistency and quality, ensuring everyone performs the task in the best possible way every single time. Next are machine and material. Machine refers to any tools, equipment, or technology used in the process. For our bitter coffee problem, this could be the coffee grinder is old and produces an inconsistent grind size, or the espresso machine's pressure gauge is broken. Material, as we saw with our zippers, refers to the raw components or information you use. For the coffee, this could be we switched to a cheaper, lower quality coffee bean, or the water filter hasn't been changed in months, so the water quality is poor. These 2 M's focus on the physical things you work with. Finally, we have measurement and Mother Nature. Measurement is all about the data you collect and how you inspect for quality. For the coffee, possible causes here might be we don't use a thermometer to check the water temperature, or the scales we use to weigh coffee beans are not calibrated. You can't control what you don't measure. Mother Nature refers to the environment, which can be both the literal and figurative workplace environment. For the coffee, a literal example could be the cafe is too cold, so the coffee cools down too fast. A figurative example could be the work environment is too hectic and stressful, leading to mistakes. Now for our third tool, which is beautifully simple but incredibly powerful, the 5 Whys. Developed by Sakichi Toyoda, the founder of Toyota Industries, this technique is a simple method for getting past the symptoms of a problem to find its underlying root cause. The idea is that by asking why, about 5 times you can drill down through the layers of an issue, just like an archaeologist digging to find a hidden artifact. It's a natural extension of our own curiosity. When a child asks why, over and over they're trying to understand the world on a deeper level. This technique applies that same powerful curiosity to problem solving. Let's try it with a simple, everyday example. Problem: your car won't start. This is the surface level symptom. Instead of just calling a tow truck, you decide to use the 5 Whys. 1. Why won't the car start? The battery is dead. This is the first why, and it gives us a direct cause but not the root cause. 2. Why is the battery dead? The alternator is not charging the battery. Okay, we're getting warmer. But why isn't the alternator working? 3. Why is the alternator not charging the battery? The alternator belt is broken. Aha, now we're getting to a real mechanical failure. 4. Why is the alternator belt broken? The belt was old and worn out, well beyond its recommended service life. We're very close now. 5. Why wasn't the old belt replaced? I haven't been following the car's recommended maintenance schedule. Bingo. Do you see what happened? The initial problem was car won't start, and the obvious fix was charge or replace the battery. But if you had stopped there, you'd have a dead battery again in a few days. The 5 Whys pushed you past the dead battery, the symptom, and the broken belt, the immediate cause, to the true root cause. The maintenance schedule was not being followed. The final effective solution is not just to replace the belt and battery, but to commit to following the car's service schedule to prevent future breakdowns. It helps you find a systemic solution, not just a temporary fix. The 5 in 5 Whys is just a guideline. Sometimes you might get to the root cause in 3 Whys, and sometimes it might take 6 or 7. The goal is to keep asking why, until you reach a cause that is a process, a policy, or a human behavior that can be changed. It's a fantastic tool to use on its own for simpler problems, or in combination with the fishbone diagram during a more complex 8D investigation. Its primary advantage is its simplicity. Anyone can use it, anywhere, without any special training or software. It encourages deeper thinking and helps teams avoid the common trap of only addressing the most obvious symptoms. We've explored 3 incredible tools from the world of professional problem solving: the comprehensive 8D process, the visual 6M fishbone diagram, and the elegantly simple 5 whys technique. The 8D process gives us a robust, team-based framework for tackling major challenges from beginning to end, ensuring our solutions are permanent and that we learn from our mistakes. Its main advantage is its thoroughness and focus on systemic change, preventing problems from ever coming back. It turns a crisis into a structured opportunity for deep, lasting improvement across an entire organization. The fishbone diagram, with its 6M categories, provides a fantastic visual method for brainstorming all the possible causes of a problem. Its great benefit is that it pushes us to think broadly and organize our thoughts in a structured way, ensuring we don't overlook potential factors in areas like process equipment or environment. It helps teams collaborate effectively, pooling their diverse knowledge into a single, coherent picture of the problem's landscape. It is the perfect tool for casting a wide net during the investigation phase of any problem. And then there's the 5 whys, a technique so simple, yet so profound. Its power lies in its ability to quickly drill down past the surface-level symptoms to find the true root cause of an issue. The advantage of the 5 whys is its accessibility and speed. It requires no special resources, just a curious mind and the discipline to keep asking why, until you arrive at an actionable cause. It's a tool that can be used every day by everyone to foster a culture of deep thinking and genuine problem solving, rather than just quick, temporary fixes. So now, it's your turn. These tools aren't just for big corporations or engineers in white coats, they are for you. The next time you face a challenge, whether it's a recurring issue at work, a group project going off the rails at school, or even why your houseplants keep wilting, try using one of these methods. Start simple with the 5 whys. For a bigger issue, sketch out a fishbone diagram. By practicing these techniques, you are not just solving a problem, you are building a new way of thinking. You are sharpening your most powerful superpower, becoming a more confident, effective, and valuable thinker. Go on, give it a try.